Alright folks, let's do number 15. A ball is tossed from an upper story building, and so let's draw this. Alright, so here's the building, here's the window, and the ball is about to be dropped at the initial speed at 8 meters per second at the angle of 20 degrees below the horizontal. So it's going to go, it's going to have that little parabolic pathway in there somewhere. And this is going to be the x-axis, and this is going to be the y-axis, and this is going to be some height right there. So that's going to be the height. Alright, so for part A, how far, let's come up with the equation. So that's going to be the equation R. R is going to be the position x and y. X here is going to be the position v naught, or in this case 8 meters per second, cosine of 20 degrees times the time it takes, and the thing says 3 seconds, so I guess we'll just put 3 seconds. And y, which is going to be 0, is going to be some initial height, or I guess I'm going to call it down positive. I don't really care anymore. 8 meters per second times sine of 20 degrees times 3 seconds minus 9.8 meters per second squared divided by 2, which is 4.9 times 3 seconds squared. So for part A, how far from the base does the ball strike the ground? Well, they do give the time, and you have given the initial and the angle, so that means that you have all the components. So all you have to do is grab your TI-84 calculator. So 8 cosine of 20 degrees times 3. And then the other one is the fuck. Oh, there you go. Alright, so for part A, the distance for D is going to be 22, what is that, 22.56. So 22.56 meters, around there, I don't know. And then this other one is going to be, the height is going to be 52.31 meters. That was pretty easy. So how long does the ball take for the ball to reach 10 meters below the level of the launching point? So we're going to reset this up. How long does it take for the ball to reach at a point 10 meters before the launching pad? So that's just another way of saying let h be 10 meters for the time where the initial velocity is 8 sine of 20 degrees multiplied by whatever that time is. So this is going to be meters per second times some time plus 9.8 meters per second squared divided by 2 t squared. So this is going to be a quadratic formula, as you can tell. So that's going to be 9.8 meters per second squared divided by 2 times t squared. That's going to be that plus 8 sine of 20 degrees meters per second times the time minus 10 meters. That's going to equal 0. So you're going to use the quadratic formula. So to solve for this, so once you use the quadratic formula, the time it takes here is going to be 1.18 seconds. So that is going to be the answer for part C. For the ball to reach 10 meters below, or that's another way of saying, since, well, you get the idea. So that's going to be the time it takes for it to reach 10 meters. So the time here is going to be 1.18 seconds. And that's it, folks. We are done. That's all it takes.